Good morning, class. Good to see everybody here today.
It's morning in California, but it's the
Okay.
afternoon here.
So here we are, these exercises. In exercises 1 and 2, find the circumference of the circle with the given radius r. State the correct unit. What do we have to know to be able to do this?
The formula.
We have to know a formula, right? What would a formula be for this?
R cosine equals pi r squared. Yep.
Like that?
Yep.
Actually, that's going to be a formula for
2
area.
pi r, 2 pi r.
Yeah, so circumference is going to be equal to 2 pi r.
Yeah.
Now, you remembered this formula up here. I'm glad you did. Also, there's another way you can rewrite this. You can write this as pi times the diameter. So they're both the same, right? And I kind of like to think of it this way, that the circumference of the circle is a little bit over 3 times the diameter of that circle. So that's just kind of a rule of thumb you can use. And so when you have that, you can say your circumference is equal to 2 pi, and we could substitute in this for r, so 2.5, and what is our answer for this going to be?
15.7.
5 pi. And what you can do is you're going to leave this in terms of pi most of the time. So it's going to be that many inches. And yes, as Angel did, you can go ahead and punch that in a calculator. But most of the time in this class, we're going to just leave things in terms of pi when we can. Okay, does that make sense?
Yeah.
So just get used to that. It's just part of the language of talking. Okay. Now next, I want you to do this one here. What you should get is you should get 9.2 pi meters is what your answer should be for this one. Okay? For number 3, you have a little bit different situation where you're given what this is, so you put in 12 is equal to 2 pi r, and you can solve by dividing by 2 pi, right? And so when you divide 2 by 12, you get 6 over pi. So, and that's going to be r, and it's going to be what units? Meters. Okay, I want you to do number 4. I'm going to call on somebody to do number 4 in half a minute. And I'm going to go get our 6th period class. Come classes to me sometime today would be nice. Okay, and we've lost some students. And we lost Jana too. Yeah, Kay's not here, so I'll save it as is here. Okay, so number 4 is going to be answered by
Ayla.
Carbon. Okay, Carmen, what do you think?
And that's 4 over time equals.
And units for that, Carmen? Feet. Okay, any questions about that? Yeah, that's it, isn't it?
What I got.
Okay, now, 5 and 6 have to do with the new type of formula that you haven't been made acquainted with yet. It's called the arc length formula. And the arc length formula is exactly what they give you in problem 5. It's this equation right here. This is arc length formula. And the formula is S is your arc length. It's equal to the radius times angle. So I'm going to write an arc length. By the way, what is an arc?
Curve going up.
Upside down parabola.
Half circle.
Okay, I heard different definitions, and every definition I heard was probably a good definition, but it has a specific thing in this. Equals radius times angle. And the angle has to be in a unit of measure called radians. Okay? So basically it's arc length equals radius times radians. But somebody said a parabola, right?
Yeah.
Well, a piece of a parabola, that is an arc. When you take a basketball shot, the path of that basketball shot is an arc. But it's not an arc according to this definition, because what is the shape of this arc? It's a piece of a circle, okay? So in the context of this, these types of problems, it's the piece of the circle. So all we have to do for problem A, for instance, and these problems A and problem B, we're going to say the arc length, S, is going to be equal to 9.9 times 4.8. And it's going to be 47.52, is that right? Anybody put that in a calculator?
Yeah.
Is that it? I just happen to remember from 5th period. That's how I remember it. So I want to choose somebody to do part B for us here. Very similar type of problem. So I'll just pick somebody for that. It's going to be Emma. So Emma, you can do part B for us here. 39.77. And what? Kilometers, right? Okay. All right. Nobody has questions about that? So are you guys pretty comfortable with using that symbolage theta?
Yeah.
And all that? Okay. But these are Greek letters. Theta is the one I think that's most commonly used. But also there's alpha, beta, and on number 6 there's a new type of Greek letter you may not have been familiar with yet. This W looking thing. This one right here, this W looking thing is called omega.
That's a lowercase.
And it's a lowercase omega. Okay? I think an uppercase is
It looks like
some kind of
Walgreens.
O. Yeah, it does look like a Walgreens symbol, doesn't it? Yeah, but it's omega, but it's the same type of thing, except this has to do with the rate, radians per second, feet per second, essentially. And so for this one right here, it's the same type of formula. So S is going to be 8.7 times 3, which equals
26.1.
26.1, thank you,
Okay.
0.1 meters per second. So what you're doing is you're taking this rotational speed, this angular speed, and converting it with this formula into actual speed. That's what you're doing. I want to choose somebody for 6B here in a minute. And this person that I choose is going to be Emily. Gives Emily. All right, what do you got here?
I got 8.06 feet per second.
Okay, feet per second, right? So you're converting radians per second into, in this case, feet per second. Okay, does that make sense?
The new girls now,
It's kind of fast.
I remember you know, her name's Carly Jones. And she used to go to
we
church.
got here before Christmas break, right?
Because there was a Carly that got here before, but
Well, they weren't.
What does she look like?
yeah, they weren't. I don't know. Her name's Carly Hanson. She used to go to church. Maddie said she sucks, but she married.
Okay. Now, what happened in my sophomore year in high school, I took chemistry. I took chemistry, and my chemistry teacher, Mr. Toffelmeyer, he was a character, he taught me something that maybe if I had to look for one thing, if I have to look back and pick one thing that I learned in high school that helped me the most, like academically, professionally, than anything else, it was what he taught me. It was how to do conversions using something that he called dimensional analysis. And basically, dimensional analysis has to do with unit conversions. And so what you do is you take the 60 miles per hour and you want to convert this to feet per second. So what I'm going to do is I'm going to put 60, I'm going to put miles here in the numerator and then hour in the denominator. And what you're doing with dimensional analysis is you're using unit conversions to convert this gradually into feet per second. And so what do you have to know to be able to figure this out? You have to know what and what.
Where you're starting with, where you're going to.
You have to know where you're starting from. We're started and we're going to feet per second. But what do we have to know to be able to close the deal? How many seconds in an hour, right?
How many feet in a mile?
And how many feet in a mile? So how many seconds do we have in an hour?
About 3,600.
So 1 hour equals 3,600 seconds. Okay, and then 1 mile,
1 mile is 5,280 feet.
I just thought it was a random number because I was like, a kid.
so Will, did you know that?
Yeah.
We have to use it in chemistry,
Yeah.
or physics.
No, physics.
In miles, 5,280, you didn't know
Yeah, we
that?
have to convert everything.
5,280.
Well, that's really good. I mean, because most people don't know that today, okay? Because it's like a forgotten thing. It was, back in my day, people knew that because people had to remember things more. Another thing is that in the track and field, it was a number that was, right now in worldwide, it's meters that are used. But back then, we used miles and half a mile and quarter mile. And so instead of having a 400-meter track, we had a quarter-mile track,
Which was 440 yards.
which is 440 yards, exactly, which is 1/4 of 1760. And then a half mile is an 880.
Yeah.
And so, see, you sound like you're a track athlete from back in my day, Will, with what you know about that. Okay, now for a bonus question here, trivia question, what's a longer distance? A mile or 1,600 meter?
They're the same.
No, they're not the same.
The mile's longer.
The mile is slightly longer. It's about, a mile is about 1,609 meters. So that's a trivia question for today. So So Angel, you're the one who actually got that. I'll give you credit for
Hey,
it.
I said it first.
About what? What'd you say?
I said the miles.
Oh, did you? Okay, well, I stand corrected.
I could have sworn they were the same.
In school they taught us.
Yes.
They're very close.
At track, they told us that it was the same.
Well,
They said you're
What it
running
was-
a mile relay, so 1,600.
They should have said.
they're very close, and so generally they are the same, but if you get down to the exactness, they're not exactly the same. They're very close to the same. You could calculate the percentage which they're close, like they're 98% the same or something like that. In fact, you could do it, right? You can calculate exactly what that is. It's 1,600 divided by 1,609, and even 1,609 isn't exactly, but, so they're 99.4% the same. So Emma, they were 99.4% the same, which is pretty close, right?
Yeah.
Can you forgive that person for saying they're the same?
No, I'm gonna go tell Caldwell during it.
Oh, are you? Okay.
Yeah.
Well, anyway, what you're going to do is gradually convert. And so what you do is use these factors to gradually change this thing to feet per second. And so what you have to say is, what do I have to do to cancel out miles? Well, I got to put miles down here, right? So what's going to go down here with the miles?
The feet.
It's going to be 1 mile per 5280 feet. And so what you've done with this conversion factor so far is you've canceled out miles over miles. And next, what do we have to cancel out? Hours. And how many seconds do we have per hour? So 3,600 right here. And so what we have is we cancel out here, and if we do this right, we're left with feet over second. So our answer is going to be 60 times 5280 divided by 3,600 feet per second. So 60 times 5280 divided by 3,600. So 88 feet per second. Okay, so that's it. So I want you to go ahead and do number 8. I'll choose somebody in half a minute and go around and give credit to my helpers for this one. These are several.
Wait, what was the ending answer? What was the answer? The first one was 88.
Just 88. Maybe you could use it 5 by the feet.
Okay, let's see here. It's going to be Angel. All right, Angel. All right, Angel, what do we got here?
66 feet per second.
66? And it's the same as the other one pretty much, right? It's 45 times 5280 divided by 3,600, right? Feet per second. Is that how you did it, Angel?
Yeah.
Okay, good. Let's go look at, now this time we're going the opposite direction. And we're given feet per second, but we want to change it to miles per hour. So here we are, 8.8 feet per second. I want to change this to miles per hour, and that person who's going to help us do that is Will or Hannah. What do you get for this?
The labor, like fences in the house.
It's just the opposite way. It's just you gotta switch the numerators and denominators.
You put the 3,600 on top of it.
Yeah. Yep, exactly.
Because the units cancel in different directions.
Basketball?
Those aren't that bad. Yeah, but. Oh, and
My wrist hurts.
stretch don't work.
I really didn't do anything yesterday.
Really separated. Oh no, what was tiring was 4 on 4, 4, 4. That was
like
awful.
It was
It was so bad. It was really no break. Your 4 people would go, we were playing with JV. Your 4 team make it go to that and it came
got
back.
six.
And you would
What'd you get?
back. We were literally doing back to
Six.
backs the whole time.
6, yes.
Because you score in the series pretty fast, so.
Yeah, you should get 6, and it's gonna look something like this here. You're gonna put 5280 down here. 5280 feet per mile. And over here, you're gonna put 3600 seconds per hour. So seconds or seconds cancel, feet or feet cancel, and you get 6 miles per hour. Is that right, Hannah?
Yes, that's what we're.
Okay, and then the last one here. I want you to go ahead and do that on your own, kind of. I want to go ahead and tell something that, so I want you just to finish that, and you'll be able to turn it in.